Hello and welcome to my tutorial on writing ionic equations. So we're going to start off with a metal acid reaction. We've got magnesium, solid, we've got hydrochloric acid, which is an aqueous solution, going to magnesium chloride, which is dissolved, it's an aqueous solution, and hydrogen gas. So my first rule is that you look at the state symbols and you keep in our ionic equation the solids, the liquids and any gases. So you identify them. So magnesium is our solid, so we're going to keep that. Let's write that in straight away. We've got two aqueous solutions, but we've got a gas here, so that is going to stay in. So let's write our hydrogen gas. So now we take our aqueous solution and we need to split it into the ions that come out of that. So we've got 2 moles of hydrochloric acid, so we're going to get 2 moles of hydrogen ions. So we write that like this, 2 moles of hydrogen ions. Don't forget the state symbol. We've also got 2 moles of chloride ions, which are going to come out of that. So our 2 moles of chloride ions can be written like that. We'll do the same over here with the aqueous solution of magnesium chloride. Now to work out the magnesium ion charge, it's in group 2, so it's going to have a 2+ charge on it. And our ions here, our chloride ions, we've got 2 of them, so 2 chloride ions, aqueous. Okay, so now we're going to only keep in the things that have changed charge. So if we look at the magnesium is neutral here. It goes to a positive ion there, so we're definitely going to keep those in. Our hydrogen ion starts off as a positive, but over here in the gas it's neutral, so we're going to keep those in. It has changed its charge. But looking at the chloride, we've got a chloride with a negative ion, a negative charge here, and over here it's got a negative charge. So that has not changed charge, so we do not want that in our ionic equation. So to write everything out in our ionic equation, we'll have our magnesium, we'll have our hydrogen ions, we're going to ignore the chloride ions, then we've got the magnesium ion here, going to our hydrogen gas over here, and it is balanced because we've got 2 hydrogen ions here which go to our 2 hydrogen atoms over here. Okay, right then, let's go on to a displacement reaction. So the displacement reaction that we're going to do is sodium added to zinc chloride, okay, which makes sodium chloride and zinc because sodium is more reactive than zinc. Okay, so let's go with the rules of keeping everything in that's either a solid, a liquid or a gas. So we've got a solid sodium, so we're definitely going to keep that in. Our zinc over here is a solid, so we're going to keep that one in. Now we have to split up our aqueous solution ions. So zinc, we have got 1 ion. Because we know that chloride always carries just 1 negative charge, because we've got 2 of them, we know that zinc has to be 2 positive, because remember that is overall neutral. We've got 2 chloride ions, so we write it like that, aqueous. Okay, so let's go over to here. So we've got 2 sodium ions and 2 chloride ions. Sodium is in group 1, so it always carries a positive charge. Chloride is in, oops, made it go a bit of a wonky shape there. Chloride, we've got 2 of them, that's going, that's in aqueous, so that's going to have a negative charge on it. Okay, let's look at what has just changed charge. The sodium, it's neutral here because it's an atom, it goes to a positive charge here, it has changed charge, we're going to keep that in. The zinc over here is a 2 positive charge. Over here it's become neutral, so we're going to keep that in. The chloride ion here and here are the same. They are our spectator ions, so we will get rid of those. So the ionic equation for that reaction would be written like this. Okay. Right, finally, let's have a look at our neutralisation reaction. Okay, so we've got hydrochloric acid, potassium hydroxide going to potassium chloride and water. It's a neutralisation reaction, so water is always made. 2 aqueous solutions here, 1 aqueous solution here, but we've got a liquid there. So we're definitely going to keep that in our final ionic equation. So now we need to go about splitting up our aqueous solutions. So we're going to have 1 hydrogen ion, which carries a positive charge. We've got 1 chloride ion. Potassium's in group 1, carries a positive charge. And the hydroxide ion carries a negative charge. Potassium carries positive charge. Chloride carries a negative charge. Right, let's look at what has changed charge. Hydrogen here goes into the liquid there. Oops, change colour. And the hydroxide ion also goes into the water. So all these things are going to be in our ionic equation. The chloride ion here and the chloride ion here, exactly the same charge, negative. So we're going to get rid of those. Our potassium ion here and our potassium ion here hasn't changed either, so we're going to get rid of there. So the ionic equation for neutralisation, which is the same for every single reaction that's a neutralisation reaction, will be H plus aqueous plus OH aqueous going to water. Okay, so that was my little tutorial on our ionic equations. If you need any help, get in touch.